My name is Pedro, and in this short video I'm going to introduce you to the core idea behind my PhD project, which was done in the ARTORG Center for Biomedical Engineering Research at the University of Bern, Switzerland. So the core idea behind the project was focused on the urinary tract. The urinary tract is composed by the kidney that produces urine. The urine goes down through the ureter until it reaches the bladder, and when the bladder contracts, the urine goes out through the urethra. However, the urinary tract is not perfect, and we all heard about kidney stones, tumors, or strictures, and when these conditions happen in the ureter, it can clamp the ureter, and then the urine cannot pass. And if the urine cannot pass, and the kidney continues to produce more and more urine, this will increase the pressure and leads to pain and discomfort, urinary tract infections, and if it's not treated, to even kidney damage. And usually what the physicians use right now to bypass these obstructions is to implant a double-J ureteral stent, which is a thin hollow tube that can be inserted in between the kidney and the bladder and bypass these obstructions. However, as our urinary tract, a ureteral stent is not perfect, and in just a few days post-implantation they can start growing incrustation and biofilm both on the inside and the outside of the stent, and these are sharp like crystals that can basically impair the longevity of this catheter, and therefore this catheter has to be replaced usually every 2 to 6 months. And normally what the companies are using now to prevent this is to use coatings and static solutions and even changing the material design of the stent. However, in my PhD, we looked into active solutions. We went ahead and used active surfaces. And the idea is that to use microcilia or micro sharp like structures on the inside and outside of the stent that can be activated using ultrasound, and when they are activated, it can clean the stent itself. So the first thing we did was to have cilia and ciliated surfaces, and we encrusted it with artificial urine, and when we activate it with ultrasound we can see that we can clean the surface, clean the incrustation from the surface, and even disintegrate bigger clusters into small debris. Since we are in a wet environment, biofilm is also prone to develop, and here we can also see that when we activate the cilia against biofilm in general, we can also release the biofilm from the surface and clean the surface in some sense. In my PhD, we not only looked into solutions, we also investigate what was happening in the core. So we try to understand what is biofilm and what is incrustation. We also saw and tried to understand where is it located. Is it more prone to develop on the top part of the stent or on the bottom part of the stent? And we also try to understand why this phenomenon is happening in the first place and try to link it with fluid dynamics. And right now we have an in-house platform where we can use to test new solutions and also to understand why this is happening. So with this, I hope I convinced you that the way to go is to use active solutions, and that with our active solutions and understanding of the fluid dynamics, we can improve the longevity of the urethral stents.